50% off. What a steal.
40% less speed.
Hello everybody, and welcome back to your favorite channel with the letters BEAUMATHS in its name, specifically in that order. And today we're going to be talking about a special kind of proportion, one that's used all the time. People love using this, it's common everywhere in the real world, but there's a lot of interesting math with it too. So you probably already know this idea to an extent. That's the idea of percentages. But we're going to talk about it a little bit more in depth and really mathematize this today. So we know that a proportion kind of tells us basically how much of a total has a certain property. For example, we could say that 3/5 of the class is named Terry. Okay, so that means that out of this whole class, 3/5 of them is named Terry. So it tells us what piece of the class has this property of being named Terry, right? And so we would say that if it was a fifth of the class instead, that's a lower proportion than if it was 3/5 of the class. Or if we had 5/5 of the class, which is the same as one being named Terry, that means the entire class is named Terry, right? So by using fractions, we're able to kind of gauge what piece of a given group has a certain property. However, there's one potential issue with this. If I said something like 3 students are named Terry, if the class is out of 4 students, well, then that means our proportion is 3/4, right? And that's a pretty high proportion. That would be probably kind of odd that 3 of the students were named Terry. However, if our class size was like 1,000 students, it wouldn't be that weird anymore that a few students share the same name, right? And we get a much smaller proportion because, well, a much smaller piece of this group of students has this property, right? So just knowing that 3 students are named Terry doesn't actually tell us much about the proportion because we need to have the context of the size of the group that they're being drawn from, right? A group of 4 students looks a lot different than a group of 1,000 students, right? And so this idea where we kind of have to think about the size that they come from in order to get our proportion is somewhat limiting, right? 3 can mean 2 very different things. This is where percentages come in. A percent, that's a way of basically having a standardized proportion. So it's always out of the same amount every time. And a percent, that comes from the Latin percentum, which means by the 100. If any of you know some French, you'll know that cent or cent means 100, right? So it's a standardized proportion where essentially 0 is your worst, 0 out of the 100, and 100 is your best. So your total then for your proportion is basically they're always out of 100. This means that if I said something like 20%, we don't have to think, is it 20 out of 60 or is it 20 out of 6 million, right? Because of this percent, we know that it's out of 100 every single time. So this standardizes what our proportions are. It fixes it to be always out of 100. So 20% is relatively low or relatively bad, right? And 80% would be relatively good or relatively high, right? Since we know it's always out of 100 by using percent, we do not need to basically get any more context for this. We just can know that 20% is always relatively low and 80% is always relatively high. We didn't need to go like we did up here and note how many it was actually out of. So this is one of the really strong advantages of percent. And because it's standardized, everyone uses it, so everyone has a really good concept of what 20% actually means or what 80% actually means. Because there's a lot of different areas in life that use percent that helps us kind of have a strong understanding and grasp of what percents actually are. So I hope that gives some motivation as to why we want to actually study percent and why percent is useful and how it is basically just a proportion, but it's standardized. So now that we have that, let's actually go on to looking at some of the mathematics of percents. So if we know percents are proportions, that means we should be able to convert percents into fractions, and we should be able to convert percents into decimals. All right, so to convert a percent into a fraction isn't too difficult because it's in the name, percent. It's out of 100, right? So if I had something like 20%, what I'm essentially doing is I'm taking this 20 and then I'm dividing by 100, right? The percent becomes this per 100, or the dividing by 100, right? And so we've converted this 20% into a fraction, and then we can simplify this, right? 20 over 100 is going to simplify down into a fifth. And that's as simple as it is, right? So a fifth, this proportion here is the same as 20%. Or another thing we could do something like, let's say 55%. Okay, well that's going to be 55 out of 100. And then this 55 out of 100, again, we can simplify that down a little bit into 11 out of 20. So 11 out of 20 is the fraction that represents this percent of 55%. And you could also have a situation like maybe 7.4%. So you can have decimal percent. So then when we go to convert this, we get 7.4 out of 100. Now, a lot of you probably don't like a decimal inside of a fraction. I don't really like it either. So what we can do to remedy this is we know how we can slide this decimal over to make this 7.4 into a 74, and that's to multiply by 10. But to keep this fraction equivalent, we also have to multiply the denominator by 10. So what we then get is 74 out of 1,000. But then we can simplify this down into 37 out of 500. So 37 out of 500 represents the fraction 7.4%. Now, we can also convert percents into decimals, and this isn't too difficult. If you already have the percent as a fraction, you could go ahead and convert the fraction into a decimal. For example, we know that 1/5 is the same as 0.2, so that means 20% has to equal 0.2. But remember, keep in mind, what are we doing to get these? Well, we're just dividing all these by 100, right? And dividing by 100 is really nice with decimals because that means we can just slide the decimal point over. So 20%, for example, that's 20 over 100. Instead of simplifying the fraction or whatever, all we have to do is dividing by 100 is sliding the decimal over twice. So we get 1, 2, we get 0.2 is the decimal for 20%. For 55%, we get 55 over 100. Slide the decimal over twice, we get 0.55. For 7.4%, we get 7.4 out of 100. Slide our decimal over twice, so we slide it over once, and then we have to slide it over again, so we'll put an imaginary 0 here. And what this gives us is 0.074. So this is the decimal that represents 7.4%. So converting percents into decimals literally just corresponds to sliding your decimal over 2 times. So this isn't too difficult, but what's the point of converting percents to fractions or percents to decimals? Well, this is going to allow us to apply percents really easily because we know that we could apply proportions to things, right, by just multiplying a fraction. That means we can also apply percents to things by multiplying a fraction. If I asked you something like, what's 30% of $40? So we want to apply this proportion to $40, right? So we basically want to figure out what piece of $40 represents 30% of it. So what we can do is we can start by converting 30% into a fraction. So we know that 30% equals 30 out of 100, which equals 3 over 10. And then to apply this to $40, we just simply multiply 3/10 with the $40. So what we end up getting is 3 times 40 is 120 over 10, which is going to be 12. So $12 is the piece of $40, which is 30% of it, right? 30% of $40 is $12. We could also do this with decimals if we wanted, where we note that 30% will be the same thing as 0.3. So then if we do 0.3 times 40, we will also get 12 again, right? So both routes work for applying this percentage. All right, so let's say I buy a drink for $7 and it has a tax on it of 12%. So what's my total cost? So the idea with tax is that you take the $7 and then you're going to multiply it by this 12%. And that's going to calculate basically how much extra you need to pay on top of this $7. That goes to things like funding the government. So if we have $7 times 12%, First of all, we have to convert this 12% into a proportion, right? Because this percent is basically just saying we're looking at a standardized proportion, but we actually need to make it into a proportion. Okay, so 12%, okay, this is 12 over 100. And then it's up to you if you want to go the fraction or the decimal route. I'm going to go the decimal route just because with dollars, right, with money, our cents are going to be represented as a decimal. So it makes more sense to go the decimal route in my opinion. So we just slide the decimal over twice. So we get $7 times 0.12. Remember, the 0.12 is representing our fraction, which is our proportion, which is our percent, right? So 7 times 0.12. So it's 7 times 12. That's going to be 84. But then because of these two decimal places, this becomes 0.84. So that means our tax is $0.84 or 84 cents, right? So then the total cost, it's not going to be 84 cents. Obviously, you're not paying less money than what the drink costs. But this is what's going to be added on top. So your total cost then is going to be the $7 plus the 84 cents. So what we end up getting is $7.84 is your total price. All right, and we can also do this with taking away a certain piece of it. So that would be with discounts. So let's say I buy a shirt for $30 with a 10% discount. What's the total cost? All right, so what we have to do is we have to calculate 10% of $30, right? But 10% written as a decimal, well, that's going to be 10 over 100. Sliding the decimal over twice, we get 0.1 times our $30. And 0.1 times $30 is going to be $3. So this $3 is basically our discount amount. So that's how much money we're going to be saving. So then what that means is that the shirt, which was $30, we're removing this discount amount of the $3, right? That's the 10% of the amount we started with. So that means our total is going to be $27. So this is how you go about calculating things like taxes or calculating things like discounts. It's always percentage based. Hopefully you're getting a good feel for how percentages are calculated by using fractions or by using decimals. Now what we're going to do is we're going to go the other way around and we're going to start with a fraction or a decimal and convert that into a percent, right? Okay, so let's say I started with a decimal of 0.39. Now, I think we can all agree that 0.39 times 1 is just itself, right? Anything times 1 is, you're just taking one copy of it, so it's going to be the same thing. But 1 we know as a percentage is 100%, right? Because 100%, that's 100 out of 100, which is just 1, right? So this is the same thing as doing 0.39 times 100%. But if we multiply by this 100, we're just going to be sliding the decimal back 2 places to get 39, and then this percent sign stays, so we get 39%. So that's as easy as converting a decimal into a percent. You basically just slide the decimal the other direction now instead of going to the left, which is what we did to go from a percent to a decimal. So for another example, let's say I had 0.592. All right, so all I have to do is if I multiply that by 100%, right, which I can do because that's just multiplying it by 1, then what we get is we get 59.2, right? I just slid the decimal back 2 places. So we get 59.2% is the percent that this decimal represents. Now, when it comes to converting fractions into percentages, one thing we could do is convert the fraction into a decimal first and then convert it into a percent. And sometimes that's the easier route. For example, if I have a third, I know a third is 0.333 and so on. But when I convert that into a percent by multiplying by 100, what I get is 33.3 repeating percent. So I started with the fraction or the proportion, right? And I converted it into its decimal form, which then allowed me to easily convert it into a percent. Now, there might be some things where it's also easy to just use the fractions. For example, if I have 1 over 50 as the fraction I'm starting with, this is something I can relatively easily put into an equivalent fraction out of 100, which is what we need for a percent, right? So if I multiply the numerator and denominator by 2 each, I'm going to get 2 out of 100, right? So now because this is out of 100, the percent, the per 100, then this means this 2 over 100 can be converted into a percentage quite easily. We just know that this is 2% because, well, the numerator is 2 and the denominator is that 100, that percent idea, right? So if the denominator of your fraction is something that can be easily converted into a 100, then by all means just convert it into an equivalent fraction that will give you your percent. But if it's something like a third, where 3 doesn't really go into 100 easily, then it's probably easier to convert it into a decimal first, and then multiply by 100% afterwards, just using the decimal into percentage conversion method. All right, so why might we care about converting fractions and decimals into percents, other than just having kind of a more complete picture of the things we can do with conversions? Well, one example is actually figuring out a percent, right? So here we're told ahead of time, okay, the tax is 12%, or it's a 10% discount. But what if we had something like 10 students in a class of 50 are named Chad? What percent of the class is named Chad? So here we're trying to figure out the percentage, right? And again, this is a meaningful thing because people in general, they understand what percents are. They know that 20% is low. They know that 70%, 80%, that's higher, right? So if we can basically convert this into a percentage, we can basically tell people kind of what piece of the class is named Chad, and they can appreciate the size of that because they have a good understanding of what percentage means. It's from 0 to 100. So what percent of the class is named Chad? Well, let's start with a proportion. So the amount of students who are named Chad is 10, right? So that's our numerator. And the total class size is 50. So that's our denominator. So now when we want to convert this into a percentage, well, we know that 50 goes into 100 easily, right? We can just multiply the numerator and denominator by 2 each, and that's going to give us 20 over 100. And since we have the dividing by 100, we know that this is 20%. So that means 20% of the class is going to be named Chad. So that's relatively low, but at the same time, 20% is maybe a pretty high number considering this is a very specific thing we're asking for them to be named Chad, right? And as another example, okay, so let's say I get 3 out of 12 questions correct on a test or something like that. So if it was 3 questions out of 4, that's not bad. But 3 out of 12, I definitely failed the test, right? I got 9 questions wrong here. But we can convert this into a percent to make this more clear. So if I take 3 out of 12, right, that's the proportion of questions I got right to the total amount of questions. Then when I convert this into a simplified fraction, this is 1 over 4, which is just 0.25. And 0.25, when I convert that into percentage by multiplying by 100%, I get 25%. So I scored 25% on this test. 0% is I got nothing right, 100% is I got everything right, and 50% is passing. But I got below 50%, so I definitely failed this test. And now we see that we can figure out actually what the percentage is by converting fractions and decimals into percentages. So before we wrap up here, some of you might be wondering, can we go over 100%? And this is a really good question. And yes, we can. And that's the nice thing about percentage, is because this kind of gives us a way to look at proportions where our numerator is bigger than our denominator. So normally when we have proportions, it's going to be something like, 5/7 of cats are black. Okay, so this is saying we have a total, and then what piece of the total represents, in this case, what piece of the total amount of cats are black, right? And this perspective doesn't really allow us to consider things like 8/7 of the cats are black. That doesn't really make sense because, well, you can't have more than the amount of cats that you're working with, right? But what we could consider is something like there's a test out of 10 marks with 1 bonus question. Okay, so there's 1 bonus question on the test. So what that means is that, let's say someone gets all of the questions right and the bonus question right, and let's say the bonus question is worth 1 mark. Then what that means is that the amount of marks they got was 11, but the test is being graded out of 10 still. So what this is 11 out of 10 is 1.1. But when I convert this into a percent, what I end up getting is 110%. So they've basically gone over 100% here. And all this means is that in this situation, you were able to get better than what the expected full amount was. The expected full amount is this 10 marks, is the 100%, right? But you can go above 100% with this bonus question, right? So percentage kind of allows us to go beyond what we were originally thinking about with regular proportions, in the sense that because percentages give us a standardized measurement for success of whatever we're measuring, it gives us a standardized measurement. We can actually look at what it means to basically exceed those standards. So if the standard is this 10 marks out of 100%, but someone gets the bonus question, they've exceeded those standards. And the 110% represents that we've exceeded those standards, right? And that's a really powerful idea, right? Because if someone just said they got 11 marks on the test, we don't know the context of it. But if it's out of 10, that means they've exceeded the standard of the 100%, right? And that is represented by us actually going over 100%. So another example would be, let's say I borrowed $10 from Daniel and he charged me 200% interest. So what that means is I borrowed $10 from him and then I gave him back the $10 later, right? But he charged me an extra amount. So basically, it put Daniel out a little bit for him to lend me the $10. So in order to kind of pay him back for putting that $10 on hold, in addition to the $10 I gave him back, I also pay him a little bit more. And the amount I'm paying him back is determined by this 200% here. So if we look at 200% of $10, so that's 200% times 10. Well, then converting this percent into a decimal, we have 200 over 100 times $10. But 200 over 100 is just 2. So we have 2 times $10, which is $20. So on top of the $10 I give Daniel back, I also have to pay him $20 more. So 200%, that's over 100%, right? Because 100% of $10 is 10, right? So I'm paying even more than $10 back. I'm paying $20 back, right? So it's a very, very high interest rate, because it's kind of ridiculous to pay him $20 just so that I could have borrowed $10 from him. I mean, imagine if I borrowed $100 from him. I would have had to pay him $200 in addition to the $100 I lent him back, right? So we know that me having to pay $20 just to borrow $10 is quite high, and that's reflected in the fact that this 200%, it exceeds 100%. It's super high. A lot of places, a lot of banks, they don't have such a crazy interest. A lot of the times, maybe it's like 10% interest or something like that, right? A little bit more reasonable than what Daniel is wanting to do here. So that's going to conclude today's video. I hope you found it interesting, and I hope you are kind of feeling more comfortable with the idea of percentages in a mathematical context. We saw that percentages can be converted into fractions and decimals, and the advantage of this is that we can apply percentages to things just like we can with proportions, right? So we can look at the piece of something that is represented by that percent, right? So we could look at 30% of $40, or we can look at the taxes on things, right? Or the discounts of things, how much we have to pay extra, or how much we get to save. But then we also saw that we can convert fractions and decimals into percentages. And this also has its advantages by actually basically being able to convert the proportion of a situation into these standardized proportions, right? So this could be used to determine the proportion of people that have a given property, right? In this case, how many students were named Chad. Or we can look at basically test scores, right? 3 questions out of 12. And another thing we saw that we could do is we could go over 100%, and this offers us some nice perspectives, whether it's going above the expected amount, right, by getting a bonus mark on a test and getting over what was the requirement for 100%, and that's reflected in the fact that we got 110%, or by showing that the interest on something or the increase of something, we can kind of get an idea for how much it's increased by using percentages over 100 as well. And we see that that reflects a very large increase relative to what we started with, right? The $20 was a very high interest relative to the $10 that we borrowed. Percentages are standardized proportions. They're used all over the place, so you're going to get a ton of practice with them in the real world. But in the next video, of course, we're going to be doing some interesting practice problems, some tough practice problems as well, because you know me, I like to give you some tough ones. But until then, you have a good one, you stay groovy, and I'll see you in the next video.